So whenever you're given information about a triangle that's in terms of angle, side, side, there are theoretically 7 different cases. There are 5 with an acute angle. Here's the angle, side, and side, and 2 with an obtuse angle. But as you'll see, this video really focuses around what's often called the ambiguous case. If we look at this second case here and want to calculate what this height is as a reference to see when you do angle side, will this second side make it down and touch this ray here or not? What you can say is, looking at A here, that the sine of A is equal to this side divided by this side. So side sub 2 over side sub 1. If you multiply both sides by side sub 1, you get side sub 1 sine of A equals sine sub 2. And if you switch around the 2 parts of the equal sign, you get down to this here. So what we see is that after you've done the angle and this first side, the question is, what is this reference height to know whether it's going to make it, not make it, just make it, or longer than just making it, and so forth. And that's always the sine of the angle times the first side. So going back to this case, the second side is shorter than that reference angle, that height. Here it's equal and it's a right triangle. This is the case where we're particularly interested in, where this second side is greater than the reference height, but less than the first height. So if we start here with angle, side, side, this is the second side. There are 2 different places where it can come down. Angle, side, it can either come down here or come down here, forming a red triangle or a green triangle. And we'll get back to that in a second. This is an equilateral triangle. This is one where the second side is greater than the first side. Now, this is the really interesting one. Let's come back here. Here's the red triangle, and here's the green triangle. Let's separate these out into a red triangle and a green triangle. If we're given specific information like 25 degrees, 9, and 5, so we can use the law of sines. Sine of 25 over 5 is the sine of C over 9. Multiplying by 9, taking the inverse sine, we get C is equal to this. Putting it into our calculator, C is approximately equal to this, and it seems to make sense because this is to scale. So C sub 1 is about 49.5 degrees. Now, if we take the second triangle, notice it has in common 25 degrees, 9, and 5. So C sub 2 is the supplement of C sub 1. So C sub 2 must equal, we can claim it's equal 180 degrees minus C sub 1. This is C sub 1 here. And that's approximately equal to 130.5 degrees. That's the ambiguous case. And of these 7 cases that it could theoretically be, this is the one that's really important. The other ones are much easier to use the law of sines. It results in 2 different angles. If you have obtuse, it could not make it, or this second side could not be long enough, or could make it down long enough, and all that you have to do is compare it to the first side to see whether it's going to do it or not. And those are the 7 different cases. Again, the one that we're focusing on is the ambiguous case, and that's the most important part of this video.